this video, we're going to look at solving absolute value equations. Okay, so let's go over some steps. Step 1. This is probably the most important step. You can't really get started until you do this. We need to isolate. I'm going to put it in all caps just to let you know it's important. We're going to isolate the absolute value sign or absolute value expression. So isolate the absolute value. Okay, that means we need to get the absolute value on one side by itself. I'll show you what that means. All right. Second, we're going to create two cases. So create two cases. And here's how we create both of our cases. We're going to take the inside of the absolute value. So we're going to take that inside of the absolute value, and we're going to set it equal to, so set equal to both the positive and negative value. So set it equal to positive and negative value of the number on the opposite side. So we'll just say set equal to the positive and negative value of opposite of equal sign. Okay, I'll show you what that means in a second. All right, so those are our first two steps, and we'll go over all these once again with some examples just to make it easier. Okay, so let's go over step 3. So step 3, we are going to solve each equation. So we'll solve both equations after we make our two cases. And then the last step is we need to check for extraneous solutions. Now, when I say extraneous, you're probably thinking, what kind of word is that? What the heck does that mean? And I'll tell you, it's going to actually be pretty easy to remember. Extraneous solutions, just real quick, they don't work in your problem. So don't work when plugged back in. So we'll say when plugged in. Okay, so essentially they're extra. So they're extra equations that we don't really need. So we just say, all right, when we plug this back in, it doesn't work, so it's extraneous, so we leave it out. Okay, so now let's look at a quick example just to get an idea, and then we'll make things harder. So let's start with the absolute value of x minus 9 equals 5. And I'll write down some of the steps over here. So once again, our first step is to isolate the absolute value. So isolate, and I'm just going to draw the absolute value sign here. Okay, so we want to isolate this whole thing. Now, to do that, let's first do this. Go to your equal sign and draw a line at your equal sign, because now you can see this is the left and this is the right. When we say isolate the absolute value sign, we mean get the absolute value sign, this whole thing, get it by itself. Now, is that absolute value sign the only thing on the left side? Yeah, you don't see anything else out there. There's nothing outside of the absolute value that's also on the left. So that means it's isolated. So this absolute value sign is isolated. That's what we mean. The next example I'll show you when it's not isolated. So now, here's what we're going to do. We're going to take this inside and we're going to split it. So that's actually step 2. So we take inside, and we're going to set that equal to positive and equal to negative, whatever's on the opposite side. Okay, so when we take the inside, we're going to say, okay, this is case 1, or I'll just say x minus 9. Now I'll draw a line down the middle, and then on this right side we'll also have x minus 9. But they're going to be equal to two different things. The first one's going to be equal to 5, which is the positive version of this. The second one's going to be equal to negative 5. So all we do is make the second case negative. Okay, we take out the absolute value signs, but we keep first what's on the opposite of our equal sign. Then for the second case, we make it negative. All right, so then we just solve each of these. So now, how do I get this x by itself? I'm going to add 9. By now we're probably pretty good at this. So x equals, let's see, that'd be what, 14? All right, on the other side, on the other equation or the other case, we're going to do the same thing. Add 9, and x equals 4. Because -5 plus 9 is equal to 4. So now, here's how you'll typically write this answer, though. Let me actually clear all this out. So we said x equals 14 and 4. Here's how you'll most likely write this. It's called set notation. You'll say x equals, and then you'll draw these brackets, and you'll say 4, 14, and we're basically saying x is equal to two things. It's the set with 4 in it and 14 in it. So that's not an ordered pair. It's just saying that these are the x values that make this equation true. Now, here's what we mean by extraneous solution. An extraneous solution, if we go back to the beginning, x minus 9 equals 15. If we say, okay, x is equal to 4 and 14. An extraneous solution happens when I plug this in, both of these x's in, and I don't get 5. Okay, so let's just see if that happens. Let's start with 4. 4 minus 9 equals 5. So the absolute value of that would be -5. The absolute value of that is equal to 5, so it checks out. So 4 is definitely a solution. It's not extraneous. Let's try 14. So 14 minus 9, the absolute value of that should equal 5. Let's see if it happens. 14 minus 9 is 5. Absolute value of 5 is 5, so that checks out. Now, let's say something didn't check out. That would be extraneous. All right? So let's go to another example. Let's make things a little bit harder. That way you can see when something's not isolated. Like, let's do this. Let's say the absolute value of y minus 1, but then on the outside of that we have plus 17 equals 23. So now hopefully you've got the steps written down, so I'm not going to rewrite those. I'll just go through those because I actually know the steps. All right, so y minus 1 plus 17. So once again, go to the equal sign and try to cut this equation in half. Now, on the left side, if we have any absolute value, we have to essentially get this entire absolute value on one side by itself. And if you notice, plus 17 is on the left with that absolute value. So this is not isolated, okay? So we need to get rid of plus 17. So if we were just solving an equation and it said x plus 17 equals 23, how would we get rid of that plus 17? We would subtract it, right? So we're going to do that same exact thing here. You treat this absolute value like it's one whole piece, and you just subtract 17 on both sides. So now, here's what we have. We have the absolute value of y minus 1 equals 23 minus 17. Because remember, what we do to one side, we do to the other. So now that's going to equal 5. So now we have, or actually that equals 6, I'm crazy. So now we have y minus 1 equals 6. So now ask yourself the same question. If we cut this equation in half, is my absolute value sign isolated? Yeah, it's on one side by itself. So now's where we can create our two cases. All right, so now our two cases, once again, you take what's in your absolute value and you use that for both cases. So we're going to say y minus 1, y minus 1. But on one case, we're going to set it equal to the positive value of what's on the opposite side, which would be 6. For the second case, you're going to take the opposite side and make it negative. So this would be -6. So those are our two cases. All right, so now this one's probably pretty easy to solve. We would just add 1, add 1. So y equals 7, add 1, add 1. So y equals -5. All right, now once again, here's how we would actually write that. We would say y equals the set with -7 or -5 and +7 in that. And then once again, we want to check our answers. So if we were to take our original problem and we said y minus 1 plus 17 equals 23, let's see if -5 and 7 give us the actual, well, let's see if one of those is extraneous. Let's see, -5 minus 1, the absolute value of that, let's see, that would be -6, so that'd be +6. 6 plus 17 is 23, so that checks out. Okay? Same thing with 7, we would say 7 minus 1, absolute value of that's going to be 6. 6 plus 17 is equal to 23. Boom. Those check out. All right, so it can be that easy to check your answers. Because I know some people don't like to check their answers, but it's that easy to check your answers. Let's do another, and then I'll show you a special case. But before we do that, let's do this. Let's say 3 times the absolute value of m plus 8 equals 39. All right, now let's go to our equal sign, make this two equations, or split this in half. Is the absolute value sign isolated? Is that expression isolated? Well, here's an easy way to find out. Draw a box around it, and if there's anything else outside of that box on the same side, then it's not isolated. So this 3 needs to go. So now think about this as if it were 3 times the absolute value. Or what if I said 3 times, or 3x equals 39? How would you get rid of 3? You divide. That's the same thing you do here. We're going to divide by 3 on both sides, and it's going to give us the absolute value of m plus 8 equals 39 divided by 3 is going to give me 13. Now, my absolute value sign is isolated because on the left, there's nothing else outside of this absolute value on that same left side. So now, once again, let me actually clear this just so I can make it easy to see. Once again, when we get our absolute value sign isolated, we're going to, that looks like 81, let me make it a little bit bigger. All right, we're going to make this, or create two cases. For each case, we take the inside of the absolute value, so m plus 8 and m plus 8. For one case, we're going to make this positive, make the value on the opposite side positive. So 13 is going to stay positive. On the other side, we're going to make it negative. And then we're just going to solve both. So minus 8, m equals, what would that be, 5. All right, then minus 8, m is going to equal negative 21. All right, so those are our two answers. Now we just need to check to make sure those answers work. So we said 3 times m plus 8 equals 39. And we said that m equals, we'll say negative 21 and 5, or we found that. All right, so now let's plug this in, see what happens. Let's start with negative 21. 3, we'll say negative 21 plus 8 equals 39. Okay, so on the inside, let's see, negative 21 plus 8, that's going to give me, what, 13, negative 13. And the absolute value of negative 13 is positive 13. 3 times 13 is 39. So that checks out. All right, if we substitute 5 in, it's going to give us the same exact thing. 5, actually, let me do this. 5 plus 8 equals 13, or 39. 5 plus 8 is 13. The absolute value of that would be 13. 3 times 13 is 39. So boom, it checks out. All right, now, hopefully you're asking me what all variations of this could I see? And let me show you a couple more. I just want to show you how this one would be set up, and then I'll see if you can finish it. Y minus 10, the absolute value of that over negative 12 equals negative 6. My question to you is, how would I isolate this absolute value sign? Because it's not isolated. How would I isolate that? How would I get rid of negative 2? Well, let's act like this were x over negative 2. equals negative 6. Now how would you get rid of negative 2? You'd multiply. You do the same thing here. You multiply by negative 2 on both sides. So now y minus 10, the absolute value of that equals 12. And this is where you'd set up your two cases and go from there. So let's see if you can actually finish this one off. But I'll go ahead and give you the answer just so you can practice. That way we can do some more examples because I don't want to bore you to death. Y should be equal to negative 2 and 22. All right, try that one, see what happens. All right, let me find a complex answer, and then I'll show you one unique situation. Okay, so we're almost done, but this one's going to be a little bit longer, so sorry if it's a touch boring. All right, let's look at pretty much the hardest example that we have to deal with, which would be something like this. That's not what I want. Thank you. Okay. 9 minus 4, absolute value, c plus 10, absolute value, equals negative 15. Now, here's what we have. We have an absolute value equation we want to solve, so this absolute value needs to be by itself on one side. And if you notice, now there's two things on the same side. We need to get rid of both. This is the two-step equation version of an absolute value equation. I know that's a lot to take in, but essentially we have to isolate this absolute value in 2 steps. So now we have to draw back from our past and say, okay, which one did we want to get rid of first? Did we want to use, because how would we get rid of 9? We'd subtract 9. How would we get rid of negative 4? We'd divide by negative 4. Which one do we want to do first? If you remember, the only time we do the multiplying step first is when there's one big fraction, and there's not one big fraction. So we're going to get rid of 9 first by subtracting 9. When I subtract 9, I'm still going to have negative 4 out in front, but now I've at least gotten one step done. I've gotten the 9 to move, but now my equal sign on the right side has, what would that be, negative 24? Yeah. All right. So now, once again, I have to do this in 2 steps. Because there was 2 separate operations outside of the absolute value, I have to do 2 separate steps to isolate the absolute value. So now let's get rid of negative 4. And once again, we're going to divide to do that. And we're going to divide on both sides. So now we can say the absolute value of c plus 10 equals 6. Now, that's not my answer, but I'm putting a box around it just so you know we're finished isolating. Okay, so now let's continue and let's try to do this entire problem. Now, hopefully you're seeing that that took a little bit of effort, so you're going to have to practice doing that, but hopefully you're following. So now let's finish this problem off. So c plus 10 equals 6. So now once again, when we do an absolute value, or when we solve an absolute value equation, we have to get the absolute value isolated. That's what we did here. Now we have to make 2 cases. We're going to take what's in the absolute value. That's going to be used for both cases. But we're going to set these equal to separate things. The first one's going to be the opposite side but positive. The second equation is going to be the opposite side but negative. All right, then we solve. We would say minus 10, minus 10. So c equals negative 4, minus 10, minus 10. C equals negative 16. So then I would write my answer like this. I would say C equals the set with negative 16 and negative 4. And I'll go ahead and tell you both of those are going to work. So now let's look at some special cases. All right, so the special cases are this. Let's say I did 16 absolute value r minus 5 absolute value equals negative 32. Okay, so here's what I want to show you, or here's what I want you to do first. Isolate the absolute value. So how am I going to do that? How can I get rid of 16? Because hopefully you're saying, wait a second, 16 is outside of the absolute value, and I can't have that out there. So you tell me, how would you isolate it? You divide. You'd be exactly right. So now, here's what I have. I have the absolute value of r minus 5 equal to negative 2. Now, you can work through this problem, but here's what you would find out. This is no solution. And I'm going to tell you why. An absolute value that is isolated, it's not possible that that is equal to a negative. I'll show you why. Okay? So, let's look at an easier example. Let's say I wanted to know the absolute value of x, and that's equal to, let's just say 7. What could x be? Well, x could be 7. If I did the absolute value of 7, that's 7. X could also be negative 7. What's the absolute value of negative 7? 7. Let's back up. Here's where we can really see the last problem. What if I said, what's x have to be in order to be negative 4? And typically, I get this response. Well, it could be 4, or negative 4. Well, the absolute value of negative 4 is 4, so that doesn't work. What about the absolute value of 4? What's that equal to? It's still 4, so that doesn't work. So it's not possible for an isolated absolute value to be equal to a negative. So when we did that previous problem and we said the absolute value of r minus 5 equals negative 2, that's not possible. It's not possible for an isolated absolute value to be negative. So we would say no solution. All right, let me show you one more example just to show you an example with an extraneous solution. If I have one. If I don't have one, then we'll say the heck with it. I'll just give you an example real quick. I won't even make you do this one. I'll just show you just the quick version. All right, let's say I had 2 absolute value h plus 8 equals 14h. All right, now that seems a little odd because of the h over here, but it really doesn't change much. Okay, now when you go through solving this, you know, we would say, I'll do this one quick. We divide by 2 to isolate the absolute value. Absolute value h plus 8 equals 7h. So now we have to break this into 2 cases. So we would say absolute value 8 or h plus 8 equals 7h. So the 2 cases would be h plus 8 equals 7h. The other one would be h plus 8 equals negative 7h. And then we would solve both. And now we actually have to move the h over. That would be the easiest way to do this. Okay, so 8 equals, what would that be, 6? Yeah, 6h. So then h actually would equal 4 over 3. All right, and I'm doing this one fast for a reason because this solving isn't really what I want you to pay attention to. It's the answers. So negative 8h, so then h is equal to negative 1. So there's our 2 answers. Okay, now watch what happens when I plug those back in. I'll go ahead and tell you, that's not what I wanted to do. I'll go ahead and tell you this. So let's rewrite. 2h plus 8 equals 14h. Now, I'll tell you, we said x equals negative 1 and 4 over 3. I'll just go ahead and tell you because I don't want to bore you to death. 4 over 3 works, okay? I'll just tell you that one checks out. Watch what happens when I plug in negative 1. 2, instead of h, we're going to plug in negative 1 plus 8 equals 14 times negative 1. So watch what happens. Negative 1 plus 8 is 7. The absolute value of 7 is 7. 2 times 7 should be equal to 14. But what's 14 times negative 1? That's negative 14. So this is like saying 14 equals negative 14, and that's not true, which means negative 1 is extraneous. So the answer is actually just 4 over 3. All right, so there's an example of extraneous. I know this is a long video and that's a lot to take in. There's just a lot of variations for absolute value equations, but with practice and reviewing a lot of these steps, you can get pretty good at these. So reach out if you need any help, but that's going to be it for this video.